Today we are going to start with the advanced map reduce concept, and these are the topics for the today. We are going to talk about like what are the different kind of the joins which we have inside the Hadoop, right? So we have concept of map side join, we have concept of reduce side join, as well as there is a concept related to the distributed cache. So we'll understand about that. Yeah. Okay. Okay. So the map and the reduce side join. So next, I think till now what we discussed is like, okay, one way of like filtering the data and segregating the data. That's one of the requirements we get in our data world while processing that data. Another common example, and I think most of you must have seen, right, the joins, right? Whenever you deal with the data, and this whole Hadoop framework is basically to deal with the data set, right? So when it comes to the data, the join also comes along with that, because until you join the data, you will not be able to get the complete view of the data, because your data set may be on the different, your data come from the different data set. So to get the holistic view of the whole data, you have to basically join them, and then you get that. So what we can do it here in the Hadoop is like we can do two kind of the join. One is map side join and one is the reduce side join. So what these two joins means is, as we know in Hadoop framework, we have the two-step process, map and the reduce. So when it comes to the join, we can combine the two data set in the map phase itself, and then we can output, or we can wait till the map finish, and once everything goes to the reduce, and then in the reducer we will combine these two data set and we will get the output. So the both way you will be able to do the join. The easier way or the default way, it will be like the reduce side join, where you are just leaving it once the map process happens. Then in the reduce, you are basically combining the data set and you are getting the output. In this reduce side join, what it happens, right, when you are doing a reduce side join, your whole data set has to be first processed by the mapper. And once the mapper output comes, then only the reducer starts, then the join process starts, and then you get the final data set. So in terms of the performance, it becomes the slow, because you are like spending a lot of the time to wait for all the data to come, and then you are starting with the join. And then another way of is doing the map side join, where you can do the join in the map phase itself. So so the challenge, right, what we have, like if you think of the map side join, if you remember the mapper, how it works, it just works on that subset of the data that you can give it to the mapper, and that subset of the data it has to join. So now if you are performing any join or some operation, and to join with the other table, like suppose if you are looking for a customer database where the you have the customer ID, and you want to look to that customer ID and find it out what is the customer name and what is the customer contact details and all those things. Now, if you divide that file into the different machine, so what will happen, you will have different blocks available there, and each of the mapper will only have the visibility of that particular block. So due to that, now if you want to do the join, since that it may happen that the customer which you are looking for, it is in another block. Now during the map side join, what will happen, the mapper will only have the visibility of that particular file itself, or that particular block itself. So due to that, you may not be able to find a matching key, and then your output may not come correctly. So that's like one of the things it can happen in terms of the map side join. So in case your table or the data set which you want to do for the map side join is small enough, like so that it is not like 500 GB of the data. It's just like few GB or few KB of the data, which can fit nowadays in the memory, right? Or if you remember the normal joins, what you have, right? You have a lot of the transaction data, but you have a smaller customer master records, right, which you join, right? So both the things are there. You join the two different data set. That's also there, and a lot of the scenarios also there where you join one bigger data set with a very small data set. So if you are in the other way, right, where you have a bigger data set and you have a very small data set, what you can do is you can go for something called the map side join, where you will do the join operation during the map phase itself. Then you have the reduce side join, where you have the two bigger data set. Both of them are so big that they cannot fit in the memory. So you have the no option, but you have to wait till the the mapper finish. And once mapper finish, you will have both the visibility of both the key. Because if you remember the reducer, what it happens, it gets all the value for that particular key. So based on that, you will get both the data set available, and then you will do the join based on the reduce phase. So that's the two, the join operation we have, the map side join and the reduce side join. Map side join, you go when you have one of the data set is small enough, which can fit in the memory, then you go for the map side join. And bigger data set, you distribute it across the cluster. And then reduce side join is where you have the two larger data set, and you want to wait till the reduce function starts, and where you have both the keys, and then you start the processing. So that is the reduce side join which we have. Okay. So now how this map side join and reduce side join works is, lost the voice, Chirag. Okay. Are you guys able to hear me? Yeah. Okay. Yeah, Sis, I'm going to show you an example. Yeah, got it back. Okay. Hitesh, what question? Okay. Splits are duplicate copy of some block. Why do we need to join the same duplicate block? It's not duplicate copy, Hitesh. It's just the the data get divided so that it doesn't fit in the hard physical limit, so it goes to the different block. It's not a duplicate copy. Okay. Okay. So let me give you an example, right? How it happens. So okay, let's come back here. Let me get a notepad. Simple. Okay. 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 So let's understand first the map side join. So now suppose if you want to join it a data set, like suppose if you have the customer data, it has something like cust ID, and then have the customer name and contact. Okay. And then you have the transaction data, which is having all those, like again a customer ID, and then multiple, I'm just, hold on, customer ID and then multiple blocks. I'm just, some data set it is having. Now, if you want to do a join, right, between these two data sets, right, so think of, right, like this way we have. Now, if you want to do a join between these two data sets, to do the join, like suppose if you want to look up, right, for each customer ID, you want to look up into this customer database, and you want to find it out, okay, what is the matching customer name and the contact we have, and then you want to basically replace it here. Now, you think of this customer ID itself is a, so we have just saw that only one line he has. Now you think of like this customer ID itself having the multiple records. Okay. Now, if you want to go for a map side join with like two bigger files which we have, and you want to do the map side join, the problem what you are going to face is, suppose this transaction data, it get divided, this much data it get divided into one block, and the remaining goes to the another block. Now, it may happen that this customer data will also get divided into different blocks, like suppose 3 blocks we have. Now, if you want to basically do the mapping or do the joining of this customer ID, it may happen that the machine where you are doing the processing, the mapper which is going to process, the input which you have provided, it may not have all the data set, because it may have this particular block only, and this block will not have the customer ID. In that case, what it will mark? It will mark it as a null and null kind of things, right? So that's not something correct, because we want to make sure that when we are doing the join, we have the both or the complete data set available, so that we can do that, right? So before we know how to handle in the map side join, in the reduce side join, how this will get handled? Now, in the reduce side join, if you think of both the data set, you will give to the reducer. Now, reducer, the key will be the customer ID. So it will be this customer ID, and this is the customer ID. So whatever the logic you will apply, whether you write your own partitioner or you write your own, or you use the default partitioner, this both customer ID from this particular record from the customer data set, right? And this particular the input data set, both are going to come to the same reducer, and since they have both the data set is available now, you can basically bring it all these two value here, and you can combine this, right? So this you can do easily in the reducer, because the reducer is eventually going to get this the same key, and since it receives the same key, it will have all the value. It can look up and it can get the value, and you can get the output. In case of the map side join, you have to make sure that whole data set is available, otherwise you will not be able to get the right join. So in that case, what you do, there is a concept associated with the map side join is that, if your data set is small, right, and that's what the restriction is. If your data set is small, what you can do that, you can make whole data set available to all the mappers. So now instead of dividing this input data set and giving to the different mappers, now what you are doing is you are basically replicating this whole input data set, and you are creating another copy of this whole in the mapper, and you are giving to another machine, and then similar machine, similar nodes in the cluster, and each of the join operation which is going to happen on each of the mapper output, now it will have the complete data set as available. So whenever it gets customer ID, it will query this customer ID, it will get the customer name and the contact, and it will be able to stamp it here, and you will get the output. So that's what in the map side join, what you have to do is you have to, one of the data set, if it is small, you can afford it to distribute that particular data set across the multiple machines, and once you distribute it across the multiple machine, it will be available to each of the map output, right? Whenever map is output, it will be able to access the data. How you distribute that, how you access that, we are going to add, like how you add this particular file to the distributed cache and retrieve that, we are going to see. But the concept wise, it is like you distribute that file across all of the machine. So when the mapper is running, it has the complete visibility of that smaller data set, and it can query the data set, get the output, and then continue with the processing. So that's the concept we have with the map side join. So what you do here, as you can see in this particular diagram, you have the big table where the records are there, and then you have the small table. So you load this data set inside the memory. That's what the distributed cache, because it has to be loaded into the memory, and it will get shared across all of the nodes. And how you do that? You use a hash table files where you can have multiple files, and all these will maintain in the hash table. So it will able to fetch all these files, and it will be distributed across all the mappers. So you can see here the distributed cache. So all of the mapper now have access to that small data file which you have loaded through the hash table files, and each of the mapper will now able to query this data set, do the join, and give you the output. So that's the concept we have with the map side join, where you take the small data set, distribute it across the machines, and keep all the data set inside the memory. That is called distributed cache. And once it is available in the distributed cache during the map side join, it will be able to access that, and it will be able to process that. And then in the reduce side join, you don't need to worry about that. So if your both the data set is large, in that case you cannot go for the map side join because it will not fit into the memory. So in that case, what you do a reduce side join where you basically pass both the key data to the reducer. And once you pass this to the reducer, what the reducer will do is, it will take both the data set, it will aggregate that, combine that, and you will get the final output. Okay. So, okay. So Hitesh says, what about the replication factor which makes duplicate copy? Which question there? Devendra says map side is good for one small data. Yes, so one data set is small, in that case you can go for map side join. Okay, and Hitesh, what about the replication factor which makes duplication copy? So here, Hitesh, is it your question related to the distributed cache? So if it is that, so this here, the only one copy, because you are not storing in the HDFS, you are storing in the memory, so that that replication factor is not going to come and play here. Okay. So the small table file, when you are distributing, you are only distributing into this hash by using this hash table files. You are putting it only into the memory. So only one copy you are going to put on each machine. So each machine will have this copy available, and they can query that, and they can run their map task on top of that. Okay. So let me show you like how to do this join using the map and the reduce framework. So we'll first see the reduce side join, then we'll come to the map side join, and then we'll see both the data set. So let me go back here. Okay. So before I go, let me explain you like what the join operation we are going to do, what the operation we have here for the join. So we have the two data set which we basically want to join it here. One is the customer data set, and another one what we have is the transaction data set. So what we want is we want to join these two data set so that and the key will be the customer ID which we have here. Right. So for each of these, the transaction which we have, this is the transaction data set we have, and we have like the transaction ID is there, which date it has the transaction took place, and then we have the customer ID. Then the amount they have spent on that particular transaction, then what kind of the equipment they buy, and then which state, and all those information is there, right? Now what our goal here is like we want to join this data set with something called the customer data set which we have. So here we have the customer data set where we have again the customer ID, the customer name, then whatever the age, profession, and all those information is there for that particular customer. So now what we want is we want to join these two data set, transaction and the customer data set, and we want to find it out how many times like one particular customer has done the transaction with us. So number we want to count like how many times like if you see here, if I highlight this 4001, you can see the multiple transaction has occurred here, right, in this file. So we want to find out like how many times the transaction has occurred and what is the amount like they have transaction. Like so each of the transaction they are spending some amount, right, for some equipment. So we want to find it like what is the total amount they have spent during all the transaction which we had, right. So once we combine these two things, instead of putting the customer ID with that, what we want is we want to replace that value by the customer name. Whatever the customer name we have, we want to fetch that value, and then we want to store it along with that customer name and whatever the number of the transaction they did it, and and what is the transaction amount we have. So with this value, we want to join these two data set, and we want to basically bring out of all these aggregated value, which we see that total number of the transaction, but along with that, we want also the customer name to be coming there instead of the customer ID. Okay. So now the first thing will be we have to what we can do is in this case, right, we can go map side join and the reduce side join, both we can do that. But here for this example, first I will show you like how to do the reduce side join. So what we are doing is we are basically passing both the data set to the reducer, and reducer will be able to do the join by having both the data set for the customer. So 4001. So it will get all these transaction data also, and as well as it will get all these the master data also, and both the data set will go to the one reducer, and reducer will be able to join these two data set. So while passing this value to the reducer, what you have to do, that one thing you have to do is you have to label these records. So this 4001, you have to tell that okay, this is the transaction record I am sending for this customer, and this 4001 which I am sending, this is the customer record which I am sending. So I will show you like two mapper implementation, where when you are processing these input data set, you will label these two records as okay, these both are two data set, and one is like transaction, one is the customer data set that has to go to the same reducer, and there the actual join will happen where you will combine these two data set and you will get the output. Okay. So data set clear, guys, what we are going to do. Okay, so let me take one and give you more example here. Okay. So now you are going to get this as the input data set, and this you are going to get as a customer details data set, right? So two data set you are going to get, and let me take one more. Okay. Okay. So now what we have to do is we have to basically join these two data sets, right? So you have to read this particular input file, and you have to find it out, okay, what is the key here? So this is the key here, and then you have to read this particular file, you have to find the key, and once you find these two things, you have to basically do whatever the logic you want to implement in terms of the join. Okay. So now how you do this reduce side join, let me show you. So first what you will do, you will start, like let's start it from here guys, okay. So let's start reading, or let's start from this one customer data set. We'll read it first and then we'll go. So now if you want to start reading this customer data set, what you want is you want access this customer ID, that's the key we want to access, and what is the associated value with that, right? What is the name we have? That's what we want to output here, right? So you will start reading this the file, other file which we have, or this file like the customer file we have, and you will finally get these two as the output, okay? 4001, and then we'll fetch this as the name, and we will tell you that okay, this 4001 key, this Christina, what we are getting, it is like a customer record we have got, right? Now we will read this particular value, that is like the transaction details we will have, and what we'll have, again we will have this transaction ID. We are not interested because that's what not the join key for us. This date, we are not using it right away, so we will not use. Then third, we will get this 4001 again as the key, so we'll read that one. And then the next what we want the transaction amount what has been processed. So that's what we will get it from here. So once we have this one, we will mark, okay, these are the transaction detail I have for that transaction. Okay. If I come to the another key, another row, it will again have these two details. I will take these two. And I will again mark these are the transaction records we have. So now what we want to do for this particular value, right? Now once you get these two data set for the 4001 record number, the customer data set, and you have these two transaction data set available, your objective is to find it out, how many times they have, done transaction with you, what is the total amount, and then finally output that value. So first what you will do, you will count it out, like how many times this transaction has happened for 4001. So you will take this input data set 4001, you will count it, okay, the total number of the transaction, in this case, like just an example, we have 2, and there is some value it has happened, right? So let me get how much it is happening. Like let me see, from some amount it is happened, right? So this is the total amount happened. And then once you have this value, you don't want to output like this way. Instead of this 4001, you want to replace it with this number, right? So what you can do is you can replace it now. Since you have both the data set, you can join it together here, and all this will be available to the same reducer. Why it will be available? Because it is the same key. So whatever the hash value or your custom partition or whatever you have implemented, it is going to make sure that if this key is same, all the value for that for both the data set is going to come to the same reducer. So when it's comes, you will be able to finally output something like this, with that twice it has occurred, and then this is the total amount what they have transacted with us, right? Once you have this output, this will go to the reducer output file, and it will be stored finally as the whole processing of this reduce side join. Is this clear, guys? What we are going to happen? What join we are going to do that? Let me know this example is clear. Then I will show you in the program how you do this whole stuff. Okay, Chirag is clear. So okay, Devinder, summarize again. Okay. So what we have is we have the two data set. One is the transaction data set, one is the customer data set. We want to do a join between these two. We have two options to do that. One is map side join, one is reduce side join. Right now what we are doing is a reduce side join. So one reduce side join, what we have to do as part of this join thing is, we have multiple transactions. So for each customer ID, we have the transactions here. So what we want is, for each customer, we want to count how many times they have done transaction with us, as well as what is the total amount of the transaction what they have done. Once we have these two numbers, what we want is, instead of output that with the customer ID, what we can do is we want to combine it with the another data set which we have, that is basically the customer record, and we want to combine these two, and we want to get the output as like the customer ID replaced by the customer name, and then the amount and how much time they have done the transaction, all those values we want to do. So basically we are joining the two data set in the reduce side, and we are trying to get the trying to accomplish basically the joined output from these two different files which we have. Okay. Okay. So is this clear now, Devinder? What is the problem? How we are going to do that? We are going to see. So here you will see that till now whatever the join operation you have done in your programming, right? Most likely SQL. So you will just write the join and you will give the data set as A and the B and you will do the join. Here you will see that when it comes to the MapReduce join Java program, it is much more involved join than whatever you have done till now, where basically you have to go on the data structure level, array level, and you have to basically find it out which particular column, which particular array index you want to bring it as a key and the associated value, and then do the join. So it is more involved join than compared to what the normal join which you see, right, by just writing the join keyword in the SQL. Okay, so let me show you the program here. Let me clean all this. Okay. So here is something we have called the the join keys, right? So let me first show you the from the driver class. So apart from setting what is the reduce join class which you are going to use, map site join class we are going to use. The one thing which you have to important is there you see the till now we have seen file input format. This is like multi file input format, so multiple inputs if you want to do that. So in our case we have the customer and we have the the transaction data set. Both of the data set we have to be processed during the mapper. So if you want to specify multiple inputs, you can use this multi-input format where you can specify the multiple input file to be processed by the mapper. So that's what we are specifying using multi-input format. And then what we are doing, we are giving each file like the customer file, we are giving it to the customer mapper class, and then the transaction file we are giving to the transaction mapper class. And then the output file, again argument 2, that is where the output we are going to store it. Now come back to the mapper class, what we are implementing here, customer mapper class. So you are getting a customer file. So the customer file is nothing but like this kind of the customer file you are getting, where we have the customer ID, name, age, profession, and all those things. So what you are doing here is like you are taking that as an input, each record you are taking as the input, and you are splitting based on the comma. So I think somebody had a question early in the class like how to split if it is a space or tab, right? So you can specify how you want to basically split your record. So you can use string tokenizer, that will by default it will split that. But if you want to specify your own split delimiter, like how you want to split it, you can specify how you want to split the record. So here in our case what we are doing is we are splitting based on the comma. So based on the comma our record will get oh, Satish, you had the question? Okay, thank you. Thanks for letting me know. Yeah, so you can see here, right, how to split the data here. Yeah. So once you split the data based on the comma, what will happen is all of this input data set, it will get split based on this one. So you will have all this data inside an array. And that's what you are going to store as a part of the array called parts, and it is a string array where you have stored all this data. Now, once you have the split of this input data set, you are not interested in all the column. All you want is you want to pick it out this customer ID and the customer name column, right? So what you are outputting from this mapper is the text part 0. So what is the part 0? That is the customer ID, because it will all go to the array. So this will be 0, 1, 2, 3, and the 4. So it will go to the 0. That's the first element of the array. So you have this output coming in the part 0, as well as you will have the part 1. That will be basically the value you want to bring it here, the customer name which you want to bring it out here. And then when you are outputting that, as I told, you have to differentiate that what is the customer record and what is the transaction record. So when you want to do a reduce side join in Hadoop framework, what you have to do is you have to label all these record that this is the customer record. So that's what you are doing is you are associating a keyword called cust with the whatever the output which you are writing here. So the key, and then you will label it as the cust, and then you will have the another part that is tab separated, and you will get the the value associated with that. So now the value which we are going to get is something like this way. So what we saw here it is actually going to come something like this way. Okay, like this way it's going to come. Okay, so that's the customer output we are going to get. Then we have the transaction output. Transaction is nothing but this data set we have, where you have the transaction ID, date, customer ID, what the transaction amount they did it, and all the state, from which state, what equipment they buy, and all those things. So now if you want to process this input data set, what you do is, again, you get this input data set, you split it based on the comma, you split the whole record, and finally what you want to fetch it out from this particular data set is, you want to fetch it out this customer ID and what is the amount they have transacted with us, right? So these are the two things we want to fetch it out. So what you are doing the context set right, and you are using part 2. So what is the part 2 here? It is 0, 1, 2. So that is the customer key, and the part 3, that is basically the amount which they have processed. So that's what you see here. This is the part 3 which we have, which is the amount which they have processed. And then we are combining these two records. So then we are labeling these records, that is by using the transaction keyword. So let me go back here. So now you have these two data set here, like this way, transactions. Okay. So now once you have these two records labeled, what you can do is you can pass this information to the reducer. So what the reducer is going to do is, reducer is basically going to take these two things, and it's able to give you the value after combining that. So how the whole combination thing it works here, guys? So you initialize some of the value, like the name. It is unknown here, blank here right now. The total sum which you want is 0. Then the count is 0. And for each of the value, what we are doing is, for whenever you are getting any value, so you will get a set of the value. So it will have the customer data set as well as it will have the transaction data set. So we are basically iterating through all of the values which we have. And first what we are looking is the part 0 equals to the transaction. So if in the first part, whatever the output we have got, if it is a transaction record, we are identifying that whether it's a transaction record or it's a customer record. So since we have added this transaction keyword there, so when you are doing this comparison, if part 0 equals transaction, so it will say true. And as soon as you see a record for a given key that has a transaction associated with that, you are going to increment the counter plus plus. So what you mean that you want to increment the counter to count it down to how many times this transaction has occurred. And then once you are increment that particular variable, you are also doing the sum of it, right? So you are basically calculating, you have a variable called sum equal to 0. So that's what you have, total equal to 0. And then in that you keep adding every time you see a value associated with for a particular customer. So this way you will get the total sum as the output. And then once you are able to iterate through all of those transaction detail, what you do is you go to the so next record which you will get from the customer record. So once you get the customer record, what you have in the customer record is just this customer key labeled as cust, and then you have the name associated with that. That is the actual name we have. So that's what you do it. If part 0 equals to the customer, you get the final as the part 1. That's the output you have. Now when it comes to the write, what you do is you basically write all these three things at the output. So you write it right. This count is an integer number, so you are using %d, and the total it will go float. So %f we have. So this is the two output you have along with the customer name which we have. So that's what we are associating it here. The text name here which we have added here. So along with the name, we are also adding this string which will having the count and the total, and that's what we are going to get at the output of this reducer. Okay. Is this clear, guys? Are you guys good with this one? Flow did you get a guys a flow like what all we are doing here? How we'll do it? I will show you. But are you guys good with the flow? Okay. Satish has a question. Yes, Satish, go ahead with your question. Chirag has a question, shouldn't you use big decimal? Yeah, you can go for big int kind of thing, or big decimal, Chirag. So here the example is simple, that's what we have used, float, but yes, you can have the data type. It's available with Hadoop. And Satish said, is there any way to identify the output of mapper? Yes, you can set the number of the reducer as 0, Satish, and you will get the output whatever the mapper is giving. Yeah. Yes. Okay. So if you see here, if you set the number of the reducer as 0, yeah, number of reducer at 0, whatever the mapper output, you will be able to get it. Okay. Okay. So is this clear, guys? All of you, are you guys good with this one? Next, I'm going to show you how we run this thing and we basically combine these two data sets. Good? Yes? No? Anything? Question? Let me know. Okay. Okay. Okay, so let me show example. I think that will make things more clear, and if not, then we'll come back and revisit the whole example. Okay, so let me take it here. Okay. Okay, let me take the same program. Maps like join. Copy. Okay. Okay. So again, guys, you can follow it like including all the external jar files. You can do it since I'm using the same project. So I have all the definitions available in the reference jar. So we are getting here. Okay. Now what we are doing in this one is we are basically giving the two input file, the customer and the transaction, and we are passing it to the two mappers, which are basically going through each of the record, labeling it as the customer record and the transaction record, giving us the desired field which we want to take it for the further join. So it takes that one, and then finally it does the join and its output. So this way you can see that whenever you write a normal join in the SQL world, how it happens, where you tell that, okay, table A, table B, and like this particular row ID. So there is a logic behind that, how that join happens, and this is some kind of a logic which you will see even in SQL, right? End of the day, they also have to write a program to do the join. So here you can see here, right? You take all those input set, and based on that, you basically identify, okay, this is the column which we have to pick it, right? So that's what you are doing here in the custom mapper. You are picking what all the columns you need from the customer data set. Then in the transaction data set, you are again picking up the column which you need from the transaction data set. And then whatever the SQL or something, you write it in normal world. So same whole things you are implementing now in the program side. Like if you want to increment that counter, you want to get the sum. So you are writing all the logic for that instead of just doing the sum or the count inside the SQL world where you do that, right? So here you have to basically write that the loop or the algorithm to how to do the count and how to do the sum for that. And that you have the final output here, which will get stored into the output file. So now if you want to run this one, you have to create the jar file. So you do export jar file next. Instead of my partitioner, you specify is reduce site join. Okay, and finish. Okay, Control L. Okay, so we have the jar file created. Now let's move this input data file which we need here. So map join. So let's go to this one. So we have this customer data set and the transaction data set which we want to give it to this input data set to do the join. So what we do is we do Hadoop fs -mkdir /user/ advanced, and then we do a reduce join. Okay, and you move this file here, Hadoop fs -put, and then you do Hadoop fs -put. Okay, so both the data set is available here. Okay. So now what you do is you give these two input to the function where it will read the customer data set and it will read the transaction data set, and once it reads that one, it will be able to basically pass these two values to these two mappers, the mapper class and the transaction mapper, and the customer and the transaction mapper, and then once it processes that, it will go to the reducer where it will do the aggregation and the combining of the data, and then you get the final output data set. So now if you come back here, how you run this Hadoop jar, and then you give this jar file name, then you specify what is the customer data set we have. So this is the customer data set we want to give it. So this is the customer data set, and this is the transaction data set we have. Okay, and then you specify the location where you want to store the output. Okay. Okay, and then hit enter. It will start the processing. And let me take some question here. This is, can we just run the reduce jar without mapper? And without mapper, Hitesh, what you will run, like it will not have anything to be processed by the reducer, right? So it will be just a empty kind of things, right? So I'm not sure exactly, right? You can run it without reducer, that makes sense, but without mapper, I'm not sure. Okay. So you need to see the main method. Okay. And Satish. Okay. Okay, Satish, what is your question? Instead of appending customer and transaction, what the question is, Satish? I'm trying to understand. What is your question? Instead of appending customer and can we just run the? Okay, that's the answer. Okay, so this job got processed. Sure, Satish. Okay. So now the job got processed. Now let's see what is the output we have got here. So you come back here. You go back. So which is the location we have stored this file? So user advanced. Okay. 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 So here hold on guys. So this is the input file, we have the customer and the transaction, and then this is the output file which we have, which says that both the records are getting combined. So you see here. So for each of the record, we got like this Christina is the name, and then how many times they have done the transaction and what is the total value they have transacted with us. Now if you come back and try to see it here. So let me show you here. So here you have this customer ID. If you see here, this one 1, 2, 3, 4, 5, 6, 7, and 8. So 8 transaction was done, and this is the amount which they have spent during each transaction. So what we are doing here is we are basically calculating what is the total amount they have spent and how many times the transaction they have done. How we are calculating that? We are calculating simple Java thing we are using here, where like whenever we see a value for a particular customer, what we are doing is we are seeing with the transaction, we are incrementing that value to the total value as whatever the value we have, and as well as we are incrementing the counter so that we get the like how many times they have done transaction with us, right? So with these two, we are able to basically get the data, aggregated data, and then we want to link it to the customer details. So that's what we have the customer file, which is again labeled as the customer, and by using that we are able to bring this value together. So we pick this particular thing, the first name, and then whatever the output we are getting, the transaction number, and how many times, number of transactions, and the ID, right? So that's what we are getting as the output here. Okay, and does the same condition holds good as in the relational DB to perform the join operation? Like both tables should have the unique common columns. Yeah, Bhaskar. So you need a column, right, which you will do the join. So that thing you will need it, right? So here, in case of that column, how it's going to work is because that column you will keep it as a key, and since it will be key, so both of the key will flow to the same reducer. So that's what we are using it here. Okay. Okay. So Devendra said I missed on the reduce side. So reduce side, what it is doing, I think is all. Devendra is what it's doing is it's taking both the records. Both the records are labeled as the transaction and the customer. So what it will do is it will look for the whether part 0 equal to transaction. If it is transaction record, all it is doing that for each record, as soon as it sees part 0 as the label as the transaction, it will do a count plus plus. So that will increment the counter since we want to count it out how many times they have done transaction with us. And also we are maintaining a variable called total for each of the customer, for each of the the customer record which we are getting. And what we are doing, we are just adding it, the value, whatever the value we get as part of this particular transaction we have got for a customer. So that part 1 we are taking and we are adding into the total. And once we are done with this one, we are fetching the customer name from there. So that is the part 1, and then we are combining that by string method, right? So we are just combining it and then we are writing the output. So that's all we are doing it here. Where is the input from the mapper in this example? Okay, and these are the key and the value which you are giving. So again, it's a line offset as the key and the value, and once you give that input, you are splitting it, and this is the finally output which you are writing it here. So the part 1, that is the part 0 is the key, and that is labeled with the customer, and the part 1, that's the value associated with that. So that's what is the key and the value you are writing. Yeah, joining based on this key, yeah. Ashish says we're mapping. Here is Ashish, right? So if you see here, so each word we are separating it here, and then so first input what we get line offset as the key and the line as the content as the value. Then once you go inside the mapper, what you are doing, you are coming up with the key, and that the key is this one, part 0. That is the customer ID. That's now the key here, labeled as the cust, and then the value is the part 1. That is the name associated with that. That's what the value output from mapper. Similar way, when you go to the transaction, again the transaction in the transaction you will have the customer ID. So that is the key and then the value associated with that. So that's the key value pair which we have here. Yeah, in two intermediate different files, Sakta, yes. Okay, you got it, Ashish? Okay. While processing data file, do we come up with any specific design like which data should undergo any map task and which one should undergo mapper? So that's what, Babu. So whenever it comes, only control you have is like which reducer will process which file. The mapper, it will be decided by the framework. So the mapper, you do not have the control in terms of like how many mappers you run and all those things. Okay. Okay. Yeah, guys. Once we have these two at the output, right? So this flow to the reducer, and reducer what it does is it basically takes this as the input, right? And if for each of the input record set which you are getting, it's basically iterating through by using the reducer iterator. So it will have all the value for a given key, and that's where it will iterate through, and it will get the count and the total number here. Okay. So I think we already ran this example, right? Yeah, okay. So, oh, we already saw the output as well. So this is the output here, okay. So the, Swagta, no, so, okay guys, so intermediate files, how it will go is, it will basically the map output will be there, but finally, that file, the input will go to the reducer in that iterator object which we have, right? So, see, okay, so you can see here how the reducer stores the value. You see here, iterator, the text and the value. So there, how that value is going to be for each key, and the value it's going to store here in the iterator for a given key. And now, for one particular input, it's going to iterate through this particular object, iterable object, and here it is going to do the sum. Okay, you got it, Sakta, where exactly the value will be stored. And Jaymohan, can you zoom intermediate file? Hey, Jaymohan, if you want to see the intermediate file, all you have to do is set the number of the reducer as 0. You will see that. Okay, and Babu, okay. No, it will not go through two files, Sakta. It will go through the iterator. Whatever the value we have in the iterator, it will just go through that and it will process that. Okay. The data we have used in the structure, what if the data was random? I mean, where arranged under column wise. If it is data, so we have to see whether how to the data is layout there, Ashwarya, and then we have to do the join. So I will show you an example, the sequence file where you will be able to access the data. So you have to come up with some property of the data, which will identify each of the record as the input record, right, uniquely, and then you will process that. I will show you how to process unstructured data. Okay. Here, this thing what we are discussing is with this join. Okay. Yes, it will have both the iterator have both the customer and the transaction data, and that's what you see here. The loop here. If you see here, it's simple, right? Till it has value, it's just iterating through each of the record for that particular key. For each key, it's going to iterate through. That's the reducer basic functionality it has. So once it iterates, all the transactions will keep iterating, and once it finds that a record has level as the customer, it will just move it here, the else part, and then rest of the things will keep continuing here. Okay. Did that answer your question, Sakta, now? Okay. So that's, guys, about the reduce side join. Let me go back and show you now the map side join. Okay, so distributed cache. Okay. So now what we saw just now is, oh, there's a question. So the two intermediate files from the two mappers get combined to create a single iterator for the, so two files get passed to the reducer during the shuffling phase, and each of the key it will go to so basically all the value for a given key and the value when it transfer from mapper to the reducer, it go to that iterator, and where it will be stored all the value for a given key. So that's the way it's going to work. So it's basically going to read that file, put that into that iterator, the structure where it will have the text and the value, and then loop through all these iterator for a given particular key. Okay. Okay, you got it. Okay. Okay. So now what we are going to see, guys, is like how to do a distributed cache where you will have your data set which will get again distributed across the machine, right? And then each time whenever you want to use the distributed cache, what you have to do is you will have to have a small data set which can be available on all the machines, and when the mapper output itself is coming, that time itself you can do a lookup to this particular distributed cache file, and you can do the join and you can get the output. So that's what the concept we have with this map side join, where a smaller data set distributed across the machine, refer it during the map phase, do the join, and give the output. So yeah, here we have used the multi input format, right? So where we have use this multiple input path, right? So because two mappers, we have customer and the transaction mapper. So earlier we were using just only one mapper to produce that, so you have one input file. Now if you want to multiple input you want to provide as a mapper, you have to use multi-input formats, and you can give the multiple paths to the mapper. Okay. Okay, so now what we are going to see is the distributed cache where we will have the two data sets. So let me first explain you what is the data set we have. So let me get you the data set we have. Okay. Okay, so there is a question. Swagata. So let me, so let's go through the program once, right? Because explaining that program line by line, it will be like too time consuming, right? So each line. So what you can do, I will suggest like let's go through the program, try to access that once, all right? And then we have question. Let's discuss it again. Okay. Yeah. Yeah. Okay. So in the distributed cache, what you do is you take the smaller dataset file and you use something called add cache file. So by using add cache file, what you do is you distribute that dataset across all the nodes, so it can be accessed by the mapper. So that's what it's a kind of a two-step process. First is like you use add cache to specify the file which you want to distribute, so that the job tracker will take care this as like as a kind of the input, and when it will create a local copy for all of the task tracker to access this particular file, because this file will be accessed now. This will get processed now across the machines, right? And then while you are doing the processing, like the map processing, what you do is you use something called the get local cache file. So when you specify the get local cache file, it will get the array of the path where the file is located. So that mapper can read that file, and it can do the basically reading that file and fetching out the value which you need to do the join, and then write the final output. Right. So in our case, what the data set we have is the two data set we have. We have like this is all the Indian state which we have, where you have the short name for the state, and then you have the complete name, and then you have the another input file which is like the short name is there, and then the total number of the population for that state is there. So now what you are doing it here is you want to join these two files, abc.dat and dc.input, and what you want to bring is that along with this whatever you see here, the short name, you want to fetch that the complete name for that state from here, and you want to bring it together in the output file, and so that it will be more readable kind of things, right? Now the number of the state is going to be very small data set, so you can easily distribute the data set without worrying about like how much space it's going to consume by using the distributed cache across the cluster, so that it can be used as a lookup file while the when you want to do the join. And this input file, other input file can be a bigger input file. In this case it's just 4 lines, but you can take a bigger input file, you can combine it, and you will be able to get the output. So how we do that? So first thing what you do is you start, right? So you can see here the number of the reduce task is 0 here. So all we are doing is we are not using any reducer here. All the join operation now we are going to do it into the mapper side. So Jay, I think Jay, you had the question like how to get the mapper output only. If you set this number of the reducer task 0, it will set that only you get the mapper output. Okay. So now what you do is first you use this add cache method and you distribute this file across all the task tracker. Okay, so you use this add cache file and you provide the location where the file is located, and it can be both. It can be local file system and SDF file system, both the places you can place. But here we are using it the SDFS file system, and you can add in the SDFS. You can add local cache file, and that also you can distribute it. Okay. So once this is done, what you are doing is you are running the myMapper class, and in the mapper class what you are doing is you are combining the content of abc.dat with the DC input file, and then you are getting the the final output. That will be the combined data set which you want to get it, right? So now what we are doing here in this particular thing is like once you distributed your file, what you do is you get that information about the file inside the map method is by using the distributed cache get local cache file. So by using the get local cache file, what you get is you get an array of the local paths where the local file is created, and once you have that one, you can basically read that file and inside the Hadoop program, and you can again they split that, and you can understand, okay, the first part is the short name of the state, and then the next part is the actual content, and then you can put into an array, and after that you can, if you want to retrieve that value, you can retrieve that value by using the key value pair, and you will be able to get the output. So in our case, this abc.dat value, what we are doing is we are distributing it, and then we are using this distribute cache get local cache file. So it will get the file which is distributed across the machine, and once you have the file equal to abc, it can have like other program can also use that file, so you have to specify which file you want to read it, right? So we are like abc.dat file, which is the file we want to read it from that whole hash table which is maintained there for the different files. So we want to read the abc.file, and once you read this file right till you go to the end of the line, you basically split all the file based on the t/t, and you get that abbreviated name as the token 0 and the state name as the token 1, and then what you put in the map like as like state and the abbreviated value and the state name, and you put it there. Now once you put it here AB map, what you can do is you can basically query this particular thing to do the join. Whenever you want to do the join, you want to basically query this particular input data set, and you can query to get the complete name for that abbreviated state. So now here what you do is you read another file, and that the file is the DC input file, which file it comes as as the short name and the like other data field which we have here. So you again split this particular file, and what you do is you get the abbreviated field, that is the part 0. So you take this part as the output, and that part as the thing which you want to query that, and you pass it AB map to get basically get that particular the value out of that, right? Or what is the corresponding state value. And once you have the output value, you set that as the state. As well, you also maintain the whole row here. So your output value is the row. So you can see here this whole value also we want to maintain. Along with that, we want to add the state there. So that's what you add it here. Output key you set it at the state, and the value you set at the row, and that's what you write using context write. You write the key and the value at the output. Okay. Once you have this one, you don't have any reducer function. All after that you have the main method, and that's it. The output which you are going to get is it's basically going to have all this the row along with this value up. It will have another the associated state value added to that, and that's what you will get the output. So that's the way you do the distributed cache. So again, just to summarize, so you have the two methods here. First is add cache file. By using add cache file, what you do is you distribute that cache file to the different nodes. And once you distribute across the nodes, what you do is you use this get local cache file to get the names of all the cache file which we have. And once you have the cache file, you do the normal file operation where you read the data, you store the data inside that internally by splitting the tab or comma, whichever separator you have, you store the data. And once you store the data, you can use that to query the data to do the further join. Okay. So for this, right, you have to understand this concept of the map, guys, how to implement map. So this is the Java thing, right? So you implement a map, and in that map function, you basically store the key and the value pair. Okay. Flow, okay. Flow of the Satish is like first the main this. So it is not main method. It's called the driver class, guys, in the MapReduce framework. So this is the driver class from where whole your programming starts, right? So once you set it right, like set mapper class, so you specify what is the mapper class we have, and then you submit the job. Once you submit the job, what it happens is the control comes to the mapper, and the mapper starts executing that. Once the framework, so once you specify what is the mapper class, what is the reducer class, the framework understands the flow. So it will take the mapper output, it will transfer to the reducer based on the default partitioner, and then you will get the final output. Yeah. So let's see that how it works. Oh, where do you specify DC input file to read? Okay, hold on. So this is the where you will give the Chirag input file, right? So you will specify add input path. So if you remember, right, whenever we write the MapReduce code, we have this file input format and add input path. That is the input it goes, and then output where the output will be stored. So these are two places where you will specify where to run this. Okay. Is that what you're asking, Chirag? Okay, you got it. Okay, cool. Okay. Hey, Shokta, is this clear to you? Are you good with this one? Any question? I will take your question towards the end, right? Whichever you had, right? If you like for the previous one, we'll discuss that. Yeah. Okay. Okay. So let's see how the distributed cache works. So let me close this one. Anybody has any other question, guys? Before I go back and find it out, this particular program. Oh, we have this one. Okay, fine. Okay, let me take this. Okay. So now to run this, one thing you have to do here, guys, is like first the abc.dat file. You can specify as a path as well, and you can do that. So in this case, what we are showing you is like, suppose suppose if you want to distribute this across, like from the program itself, what you can do that you can just add the name directly here, right? So that also is the one way to give the URL, right, and it will take that one. So that's the one way to do that. Otherwise, if you want to pass this name as a part of argument, you can give that also like argument 1, and instead of that, it will take that and then it will distribute that. Okay. So I've tried to keep like all the concept with the different examples so that you come to know all those things. So okay, so before we do that, let me show you. So currently the file is there, Hadoop fs-ls / oh, it's not typing here. Okay, Hadoop fs-ls. If I do slash here, so you will see here the abc.file I have here, Hadoop fs-cat. Okay, so this file is already there in the HDFS. So now once we will run this one, what will happen? This file copy, suppose if you think of this as a 100 node cluster, so this file will get copied to all the 100 machines, and it will get basically the it will get basically processed on all of those machines when the mapper will run on that. So now let me do a cleanup here. Okay, so let me see the data set we have. Okay, so here abc.in, that file already there. We will move this input file to the Hadoop. So Hadoop fs-mkdir/user/advanced/distributed. DC input, and then you pass. Okay, so this is the input file we have. Now what you can do is, did we create the jar file out of it? I'm not sure. Let me do that. So you do export jar file next. Yeah. So instead of reduce set join, .jar. Okay. So we have distributed cache. So how you run Hadoop jar, then you give the jar file name, and then you provide the input path what we have, and then you provide yeah, output path. Yeah. Okay, so now if you go to here, Hadoop fs-ls, so this is the only mapper we have, so you can see here. So you can see here all this, the state name, and then the rest of the content, it came together. Right. So here we have distributed that the file, the cache file, the file which has this detail across all of the machine, and then we have used that during the program to run that and basically do the lookup, combine that, and get the output. Okay, is this clear, guys? How to do basically distribute the file, how to again get that file and combine it in the mapper and then get the output.